Okay, so we're going to be working with our truth tables. The first one is conjunctions. We have the truth table for that. And like we said, our P and Q columns will always be the same. And I'm just going to make the comment that comes from, if I have option P, it's either true or false. If I have option Q, if I have option Q, it's either true or false, but since I didn't know if I would use the first one, I have to put true or the second one, I have to put true or false off of each one. So then that way my tree diagram would be true, 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 false, false, true, false, false. And that's where these come from. So that's where every single time we'll write down P and Q, and we would just have this every single time. So that's the standard part of all of our truth tables. I'm going to go ahead and get this out the way. But we talked about disjunctions. The conjunctions are and statements, so both have to be, we have P and Q. We talked about those already. And then this is your or statement. So one or the other must be true for the disjunction to be true. Negation's probably the easiest one. If P is true, then negate it, you would say it's false. And if P is false, you would negate it and say if it's true. So in the notes that we talked about a lot of that, but we're going to go ahead and work some examples. These first couple ones can seem a little bit tricky because these really just check your content of how well you know these, and you're just getting started with it. We haven't grinded through a lot of the problems yet, so these might be tough up front, but just hang in there because you'll grasp this better as we start getting through the truth tables. But it says, if Q is false, what must be the truth value of P and not Q and Q? So first of all we know in this one, and this is that this is false. And this Q is false, but what is not false? True. So I'm just going to put a T here. Enough to know that for that whole thing to be false, we know that this, when we do evaluate this and this, that it's automatically going to be false because it's a conjunction. So it says if Q is false, then P and not Q and Q must be false since both conjuncts, both parts of the conjunction must be true for the compound statement to be true. So for us to have a true and statement right here, then both parts of these must be true. And since we know this one's not, it's automatically false. Okay, we don't even know necessarily P, but we know enough information that we know that that's going to come out false. All right, so our next one, if not P or Q is true, what must be the truth values of the component statements? So if we know this entire thing is true, so not P or Q, the whole thing is true, that's what it said. Then it wants to know about those. So if we were to have false or false, right? If you have a false or false, that means it's false. And then if you do not false, then it's true. So what do we know about P and Q? They both, therefore, they both must be false. Okay? Because that's a disjunction. So when we're looking at the disjunction, the only way we get false there is if both are false. So you kind of go back up and you can look at your disjunctions to see. All right. This next set will say, let P be a false statement and Q be a true statement. Find the truth value. So P or not Q. But first of all, P is false. So P is false. or not, and I'm not going to make any evaluations yet. I'm always going to rewrite it first. So P was false, so I'll put F, or not, and Q is what? True. Now I can calculate that. I'm going to leave false alone, or what's not true equal to? False. So what I want to do is go to my disjunction, false or false. If you look back up, false or false in the disjunction is what? False, false. Yep. All right, we're going to calculate the next one. Not, plug in P, we said P was false, and not, and we said Q is true. So this is what we're going to work with. You always work from the inside out. So first of all, our first evaluation is just going to be, I'm going to leave this alone, leave this alone. Not true is false. So that'll be my first calculation. False and false. False and false. Go back up to your conjunction. Over here, false and false is what? False. Alright? Remember, that's the one I said, if Tom and Jane go to the movie, well, Tom didn't go, Jane didn't go, so this statement is a false statement. So that's your conjunction, so you would just say false. And then what's not false? True. So the entire statement, not P and not Q, or the negation of P and not Q is a better way to say that. All right, try this on your own. See how you do. P and not Q. So the first step, always write your statement before you try to evaluate it. If you do too much at one time, it's where you make mistakes. So we said P is false, Q is true, so that means false and false. Did you get that? Okay, so some very basic ones. All right, our next set will say, let P be true and Q and R be false. So we're going to have some multiple things. Now we have three different statements. We have P, we have Q, and we have R. And it says find the truth table. So now we have compound statements going on. Kind of like order of operations, we're going to work with all of the parentheses first. We said P is true, R is false, and Q is false. All right, so here's our setup. The first thing we want to do is true and false. What do we get there? It's a true and a false in our conjunction. So you go here, true, false is false. Good. And I'll not arrow up so much, but false. What is not false? True. So we evaluate that. So now our last evaluation is false or true. And if you go to the disjunction table, false or true? True. Okay? We're going to go to the right this time and evaluate P and Q or R. So P we said is true. Q was false. R was false. Order of operations, we're going to take care of the right side first, so I'm just going to bring this down. False or false? False or false is disjunction table. You go there and you just get false. Now we go to the conjunction table for T and F. So T and F. Get false. The next one we're we're going to do P and Q, then negate it. And then on the right side, we're going to do R or not Q. Okay, so let's just rewrite the problem. So P was true, Q is false, R is false, Q is false. Okay, so just like order of operations say, we got to evaluate this part and then negate it. So true and false. So we go to the conjunction table, and true and false gets us what? Good, false. Now over here, I'm going to just rewrite, but I'm going to evaluate not false. Not false is true. All right. Not false on my left is true. And then over here, I need to evaluate this. So go to disjunction and go to FT, false true. The false true scenario is true. So now it's a conjunction and. If I have true and true, both of them are true, then you have a true statement. All right. Let's see a different look at that. We're still going to be doing the same thing. It's just going to be a different presentation to you. So to say, well, this time they specifically told us P was true or Q was false or vice versa. Well, this time it says let P be 16 less 8. Let Q be 5 is not greater than 4. And let R be 17 is less than or equal to 17. Find the truth values. All we got to do, first of all, is go up there and say, are those inequalities true or false? And we're going to tag true or false to them, and then do the same thing we just did. So, when I look at that, that means the same thing as P is 16 less than 8. No, so P is a false statement. Q is 5 not greater than 4. First of all, here's my question to you. Is 5 greater than 4? Yes. Yeah, so when it's saying 5 is not greater than 4, false. And my last one is R is 17 is less than or equal to 17. True because of the equal to bar. So that one's true. So we just did R is true. So the only thing in this particular one is they made us do an extra step. They gave us something that we had to determine the value, and then now we're going to do the same information, use the same information to calculate. So P we found to be false, and R we found to be true. So we're going to do a conjunction of false and true, which is false. Good. I'm going to rewrite my problem. Not Q was false, not R was true this time. So now I'm going to calculate not false is true, and not true is false. So really what I need to know is the disjunction of true false. True. All right, and then now we're going to do P, we said is false, Q is false. Fill in your problem first, always. Don't try to do calculations until you do that step first. Now, we're going to work with our left side. False and false is still false. And then if I have false or true, it's true. And the more we do these, the better you'll get at those conjunction, disjunction, negation tables to know them. And so it's kind of just working through them. Give the number of rows in the truth table for each compound statement. Okay. first of all, let's just talk about how many simple statements are. Not the whole entire compound thing, but how many different simple statements do we have? P, Q, R, and S, right? So you agree with me? We have 4 of them. So let's just do it this way. Since there are 4 simple statements, now P, Q, R, S, we have 2 to the n, which is 2 to the 4, 16 rows in the truth table. So our answer is 16. So count the simple statements. All right, the next one says construct the truth table for each compound statement. Now, I already did this ahead of time, like the work for it, but I want you to know that you're going to start every problem and write down your PQ every single time. Your left-hand side will be the same. You will always write that down. Now, I started filling in the top right, but you're going to start with a blank slate, and it'll always be PQ. Now, the why I chose to do not P is because I looked at my statement up there, and I saw that I needed not P. So I made that my next one. And then then after they gave me all the parts that I would need, then I worked the entire conjunction. So it's kind of like a build-up. When you're working with truth tables, if you write every component that you need, in no particular order, it doesn't have to go in, okay? But then you can just work these out, and you'll see as we go. So I have PQ, and then I decided to do not P because I saw not P up here. So I did not P just because it's going to be easier to work with. So I did not P. And to calculate not P, you're going to look at P and do the exact opposite of it. So when P is true, not P is false. When P is true, false, false, true, false, true. So basically negate it. Okay. Now, the next thing I want to do is I see that I have all components. I have the not P and I have Q already. So now I'm ready to do my entire statement, not P or Q. So you want to compare this one with this one. Okay, and we want to use a conjunction. So we're going to use our conjunction table. So not P has to be first. So not P has to be first. So we have not P and Q. What happens if you have false, true? False. What happens if you get false, false? What happens if you get true, true? True. What happens if you get true, false? False. So this is the answer. This will be your answer to all of the truth table values for our problem. Now, the only thing you have to be careful with is order matters. So basically, when I fill out my truth table, it's like doing all your scratch work before ahead of time. So I calculate everything to get it as simple as possible, and then my last and final answer will be comparing what I'm evaluating to the right, but I have to keep it in order. If the not P comes first, I have to calculate it first, right? And then Q. So next one, like I said, I automatically every time do PQ. That will never change. Now, when I look up in my problem, let me take this. Did I say true? When I look up in my problem, I see that I have this going on, and then I have to negate it. So I chose this to be one of my statements in my truth table that I worked on, and then for my final, I negated that answer. All right, so the left, those columns are all the same. So that's why I chose those. Now I'm going to do P and Q. So P and Q. So if you get true, true, what do we have? True. If you get true, false, you have false. Look in your conjunction. True, true, true.
That's false, true.
False, true, false. Okay, so pull those from your conjunction table and you get true, false, false, false. Okay, straight from your conjunction table. Now, what the real question is we want to know the truth table for not that. So we just negate everything that we just calculated. So what would that give us? False, true, true, true. And sometimes you'll see it like this in my math lab. False, true, true. And then just like over here, this one would have been false, false, true, false. Okay, so this one I kind of just set it up. Let's just talk about what some components that we can put. And I like to do the more simple to more complex as I move to the right. So first of all, I always have my P and Q. Look up in my problem and tell me something else I need. Not P. What else do I need? Not Q. So I'm going to choose, not that any order matters because I know I have to take that into account. I'm going to choose not P here. I'm going to choose not Q. Let's go ahead and do those and then we'll do some more. First of all, not P is easy. Look at your P column and do not P. So tell me what we would get. False, false, true, true. Now look at Q column and do opposite of that for not Q. False, true, false, true. That's pretty easy. Now I look back at my problem again and I see that at some point I'm going to need Q or not P. Right? At some point I'm going to need that evaluation. And so let's go ahead and do that. So we want to look at column Q. Make sure you do it in this order too. So first thing I'm going to do is compare this one with not P, and I want to do a disjunction for it. So it's an OR problem. So go to my disjunction, and I look when I have true, false. So those are the two I'm going to compare. True, false, you get what? True. False, actually, let me do this in purple. I got true. Then when I had the other one, I get false, true, true. When you compare this column to this column using a disjunction. All right, and then the last one is going to be my solution. So my solution is I want to know what Q or not P or not Q, the truth table for that. So when I highlight what I'm looking at, I want to compare this one, which is this one needs to go first, and not Q needs to be the second one. So I'm going to be looking at true, false for or false, true. So let's go back to the first one. Since I'm going to do a disjunction, true, false is what? True. What about false, true? True. What about true, false? True. And what about true, true? True. So this one is, and there's a special name for that. What's that called? Tautology, right? So Basically, we use it kind of like scratch work as we build our tables. And order doesn't necessarily matter when you're picking and choose, well, what do I want to put in my table to kind of break this down into a simple statement so that it's easier for me. Order doesn't matter as in how you fill in your table, but it very much matters when you evaluate a statement. Okay, so just keep that in mind and highlight, like keep yourself zoned in on the highlighted ones because that's what you're going to compare. And at all times, we can only compare two things at a time. So you try to start doing multiple things, and that's where you make mistakes. All right, so the next thing, we're going to move to section 3.3 now. And this is conditional statements. And we already took the time to write down if P, then Q. Sometimes that's also said if P implies Q, where P is the antecedent and Q is the consequent. We did the notation for that a little bit earlier. Negation of P, if P then Q, is P and not Q. And what's equivalent to that is not P or Q. So that's just some previous information that we jotted down before we started. We also talked about a statement that's always true, no matter what the truth value is, called a tautology. And we also recognize that there's two circuits we're going to look at, a series circuit in which P and Q are all in the same line all the way across, and then a parallel where it breaks out into two parallel, a top and a bottom circuit. So we're going to work with some of this. And there's some similarities in these. So you have true or false. So the first thing, true implies false. So we're going to go back and recall when we looked at this, we said there's only one case in which you get false, right? And that's the one with the star by it. All other implications are going to be true except for the true-false part right there. So if you have true, and is 7 less than 3? 7 less than 3 is false. So what we're going to calculate is if true, then false. What's it give us? That's the only case in which you get false. Okay? And then you'll go ahead and do the next one. All right, so we have false. Is 5 not equal to 5? Is that true or false? That's a false statement. So false implies false is true. It is true there. So now, just like we talked before, we let statements be actual statements. So we let S be a formal statement. She has a bird for a pet. We let P be he trains dogs. Let M be they raise alpacas. Express in words. So when you have not M implies P, not M implies P, what do you think we could say there? M is alpacas. They raise alpacas. So we can say, since it's not that, we can say if, because that's an if statement, if they do not raise alpacas, then what's the next one? What's P? He trains dogs. Then he trains dogs. the next one is S, which is if she has a bird as a pet. Then M is they raise alpacas, so M is they raise alpacas. What's this mean? And he trains dogs. Good. Okay. All right, take a few minutes on this next part and see what you can do. This time you're going to rewrite it as they're going to give you the statement written out in sentence form, and you use the symbols to calculate that. So the opposite. All right, so my first one, it says B is I ride a bike, S is it snows, P is the play is canceled. Right. So if I ride my bike, then the play is canceled. So
Not
B is if I ride my bike. So if I ride my bike, then P. Right? If B, then P. That's it. The next one is if I do not ride my bike. So what do we have there? Not B implies then it does not snow. Not S. Good. If I ride my bike, I'll ride my bike if it does not snow. What's the if part? The if it because it's an if then statement. So which one has to come first? If, yeah, the if has to come first because it's an if then statement. So if it does not snow, so tell me what's first. Not S implies what will happen if that's the case. B. So don't let that trick you up. Be careful though, because those are if then statements and it has to come in that order. All right. Find the truth value. P and R are false. Q is true. So first of all, we said we always just fill in R was false and Q is true. Now, calculate any not false is true. So we want to know in an if-then statement, if we get true, if true, then true, what do you get? True. All right. We calculate not true, false, or false. So first step, plug in values. Next, do any simple evaluations. Not true is false. False and false, a conjunction, is false. If false, then false is a what statement? True. Remember we said all of these are true except for one case, right? All of these are going to be true except for one case, the true false. So, here we go, the next one. P we said is false. Not, and then Q we said is true. Not doing too much at one time. I'm just going to take our time and work through this. So not P is false. Not R is false. So now let's go through and take care of all our negations. Not true is false. Not false is true. Not false is true. Next step was negations. Next step, let's deal with, we got to do the if then on the left, and then we got to do the conjunction on the right, and then the last step will be to take the if then on that. So if false, then false is true. If you true and true for conjunction is true. So now our last underline is if true, then true. That statement is true. Okay? Practice this one. See if you can do this one. So, take your time and move through it. You're going to have, we always start with PQ, but tell me some components that I can put in my table. So I'm going to have what? I need a not P. Good. My next thing is I'm going to need that parenthesis taken care of. So I'm going to have a not P implies Q next. And then my last one will be my final entire statement that I'm going to calculate.
So we put the parentheses with that. Not
Yes. Mm-hmm. All right, let's look at this. All right, so here we go. You told me that we could use a not P, and we can use the not P implies Q to break it down, and then we'll do the entire compound statement to calculate our final answer. So just filling in not P, that's easy. So not P is negate P. And then my next thing is I want to do not P, Q. And I need to do it in that order. Not P implies Q. So if I look at it and I go false, true, I'm going to get true. If I do false, false, I'm going to get true. True, true, I have true. True, false is the only scenario in an if-then that calculates false. So basically, highlight those two. So I'm going to go back so it takes it off. And I'm going to plug those back in. So we just got true, 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 false. Okay? And I only did that so I can highlight two at a time so you can really see what I'm working with. Now, for my last one, I want to look at the not P implies Q and analyze it with the P statement. So I'm going to do those in that order. So I'm going to say this one, true, true, true implies true is what? True. Good. What about true, true? True. Again. What about true, false? False. It's the only one. And then what about false, false? True. So let me take that off just for the highlight. So we got true, true, false, true. So it can look like this. True, true, false, true. Okay. So I use the highlights to show you what to compare and make sure you keep order matters when you actually calculate the statements, the truth table. So the next part, we now are given a circuit and they want us to write a logical statement to represent the circuit. Now we said if it's on top of each other, it's parallel, and if it's even with it, then it's going to be a series. So okay, so we're going to look at, so the top part, we got a parallel, it's kind of two things in one, right? So on the top, that P and Q is a series, and on the bottom, that P and Q is a series, but together, the top and the bottom make a parallel. Okay, you see that? So how that looks is, I'm going to have, let me change color here. I have P and Q in the top. And I also have P and, actually it looks like not Q, is that right? Yeah, I think there's a little tilde there. So I have a not Q in the bottom. Those are series, but I have an or between those. So it's kind of like you read it, right? That makes sense that if I was on this thing, I would either have to go up or I would have to go down, right? So, but up, these are together, and on the bottom, these are together, and this is just saying you got to go up or down, right? So that's, I mean, it's kind of hard to get all that at first, but that's how we'll look at it. So the next one, let's see, I start with just the P, as you want to think, it says it's a circuit, so you want to think like electricity. If it's moving through and it hits that circuit, what would it do? So I'm going to get to it, I hit P, but then if I'm hitting P, then what happens here? What do you think? Or, good. I don't know why it's going crazy. So P, I'm either going to go up or what? Down. So P or R. It's either going to be R if I go up or it's going to be Q if I go down. So P and R or Q. Okay. So I know at some point I'm going to have an or because it's a parallel circuit. So I'm just going to start with the top one first. Not that that matters. I could have started with the other one, but here we go. I have P. Or what was the other thing I could have had? If I went the other direction, if I went down, what would I have? Not Q. And since they're together in the same one, and very good. And R. So the series, basically for you, is if it's in a line together as a series, it keeps going, you use a conjunction. It's an and statement. If I split you in two different directions, top or bottom, into a parallel, you're going to have to use a or at some point because you're telling circuit, whether it's electricity or whatever you have going through there, it's got to pick one direction or the other. And now we're going to do the opposite. This time they're going to give us the logical statement, and we're going to make a diagram to try to express what circuit may look like. So this first one, I go across the P. So I start here, and I hit a P. And then, what's that statement that's next? It's an or, right? So tell me what's going to happen. We're going to split it, right, into a parallel circuit. So it's either going to go up or down. So tell me what can be in the top. Q. And what can be in the bottom? Not P. And you just continue it like that. So go back and look at it and see if it makes sense, because it's usually easier for us to go from the diagram to the statement than it is vice versa. But read it. Did you go to P and then you had the option to go Q or not P? Looks good. Now this one's a little bit tricky because you have not P and not Q. First of all, what would not P and not Q be? What's the key indicator in there? The conjunction. So conjunction means and it means what? On the same line. So I'm going to have not P. Then I'm going to have not Q. That takes care of the first part. But then now this says and not R. So what happens? Just keep going on. So what else do I have? An R there. Not R. Not R. So conjunction indicates to you you're going to have a series across. A disjunction, an or statement, and that makes sure it's going to split you into parallel circuits where like you have a top or a bottom option. It makes you choose. Do you go up or do you go down? And so here you just break that apart to where you just keep going. And in the case that it's not P's, that's just leave them there. Not P, not Q, not R. Okay? And that looks like that's a wrap.